Okay, below is a sketch. This is all velocity time graphs. And remember that we have distance or displacement, then we have velocity or speed, and then we have acceleration. So each one, so distance is just itself, velocity is distance over time, and acceleration is distance over time squared. So below is the sketch of a speed time graph, so we're looking at velocity, for a cyclist moving along a road for 7 seconds. Work out the acceleration for the first 3 seconds. So because this is GCSE and it's not a GCSE you do differentiation in, you literally look at this. So we are going to do the difference in y over the difference in x, which means that the difference in y is between 2 and 5, so that's 3 over 3. So the acceleration for the first 3 seconds is 1 metre per second squared. Okay, calculate the total distance covered by the cyclist. So what we do for that is we look at the area underneath the graph. So for that, we know this area here is between 3 and 7, so that's 4. 4 times 5 is 20 metres. Between 0 and 3 and up to 2, that's 6 metres. And then this is 3 by 3, as we established before, but 3 by 3 is 9, 9 divided by 2 metres. So that means we've got 20, 26 plus 4.5, which is 26 plus 4.5 is 30.5 metres. Next. Okay, a sprinter runs a race of 200 metres. His total time in the race is 20.32, and below is a sketch of the speed time graph for the motion of the sprinter. Now, it would be relatively easy to find, without doing much work, what his speed was overall. So his, his mean speed would be 200 over 20.3, so it would be about 10. But we're trying to work out, firstly, the maximum speed of the sprinter during this race. So we only know that the total distance covered is 200. We know that between 5 and 20.32, so that's 15.32, so that's time, he did x. Okay, and then that's plus x over 2 times 5, because that's where that is, so that's 5, but we don't know what that is. Okay, so we've got this. Right. I'm going to say that's 15.32 x, because you're just timesing this bit by that bit. Okay, let's times out by 2, so we get 400 equals 5x plus 30.64, and that means 30x, so 35.64x equals 400. So we divide that through by that using a calculator, and we find out that the maximum acceleration, or the maximum speed, is 11.2. So we now know that this is 11.2 here. Right, what's the next question? So the next part of the question is calculate the distance covered by the sprinter in the first 5 seconds of the race. So we know that that's just this bit here. So it would be 5 times 11.2 divided by 2. So it would give us the answer. So that is, let's go back to the beginning and make this do that. Okay, 5 times 11.2 over 2, which is 5 times 1.2 equals divided by 2 equals 28. That's only using a certain amount of figures.